Welcome to Mr. Math Academy. Grow your math brain.
Hello friends, welcome back to Mr. Math Academy. So here in this video we discuss the one more numerical on IC engines. Okay, so in this problem it's a simple, the concept is very simple. If you know the formula on the IC engines, we can solve any kind of the problem. Only thing is what we should have to know some basic concept, which are the terms he has given, okay, and what we need to find out. Okay, now in this problem he has given that it's a 4-stroke engine and he has given the inner diameter of a cylinder is a 200 mm, and again he has given the stroke length is 300 mm. Okay, again he has given that which rotates, the engine will rotate in a 300 rpm revolutions per minute, and after that, so effective brake load he has given it's a 500 kg. So effective brake load means, okay, it's something like, okay, it's a the value what he has given effective brake load means it gives the value of W minus S, where W indicates it's a dead weight and this S indicates it's a spring balance reading. Effective means we should have to consider by taking both the terms here, that is W minus S value. Okay, where it comes, where it is useful to calculate the brake power. Okay, in that case we should have to calculate the required torque here, that is a torque we need to find out. In that case this W minus S will help here. Okay, we'll just see later. Now again he has given the mean circumference of the brake drum. Okay, the mean circumference of the brake drum is, we can take this is a 2 pi r into b here, that is the circumference of the brake drum, that is a 400 mm is given. Now he has given the mean effective pressure is a 6 bar. Okay, now these are the data what he has given. Now we need to find out what is the indicated power, that is the power developed inside the cylinder, and we need to find out what is the brake power as well as the mechanical efficiency of the engine here. Now we just find out the what is the indicated power first here. Now we know that the indicated power is given by, so it's a X PLA N dash I'll consider by 60 into 1000. We'll be having a different formulas here based on the simplification. Now just I'll consider X plan by 60 into 1000 here to calculate the indicated power. Now here in this case the X indicates it's a number of cylinders. Now in this problem he has not given whether it's a single cylinder or a multi-cylinder or how many number of cylinders he has not given. So I'll just assume that X is equal to 1. So I'll just take here, assume X is equal to 1, that is the number of cylinders. So since he has not given, I'll just assume it's a 1 here. Now I'll just take this is a 1. Now mean effective pressure we need to substitute in terms of the Newton per meter square, but he has given in terms of the bar here. I just take 6 into 10 power 5 Newton per meter square, that will be the mean effective pressure. Now the length, it's nothing but a stroke length, so 300 mm is given, so I'll just take in terms of the meter, so this becomes 0.3. Again the pi area we need to find out, so area becomes pi d square by 4, so the diameter of a cylinder is 200 mm. I'll just take in terms of the meter here, so directly I'll take here pi 0.2 square by 4, that gives the area of a cylinder, and N dash. So N dash means it's a speed of the engine. So since it's a 4-stroke engine, we have to take that speed what he has given, the 300 rpm, half of that. So why we have to take half of that? So because for every 2 revolutions we are going to generate the power, that is the indicated power. That's why we have to take, this is a 300 rpm which rotates, so half of we have to take the 2 here. Now but in case of the 2-stroke engine we have to take the same speed, whatever the speed it is there, so we have to take that itself here when we are calculating for the 2-stroke engine. But for the 4-stroke engine we have to take this N dash is nothing but half of the given speed, okay, by 60 into 1000. Now we just simplify this, we are going to get the indicated power as, after simplification the value what I am getting here is, it's a 14.14, it's a kilowatt. Okay, now this is what the somewhat very simple here. Now we just find out what is the again the brake power, then we will go for the mechanical efficiency for this case. Now the brake power is given by what, it's a 2 pi nt by 60,000 here. Now in this case the speed here, the n is nothing but the N dash itself. Okay. So, okay, here the n is nothing but the given speed itself. We have to take in place when we are calculating the brake power, the actual speed what we have to take here. But only thing is, in calculation of the indicated power, we have to take half of that given speed here. Now, the T is unknown here for us. The T, capital T, that is a torque which is developed by the engine, is an unknown part here. So, we need to find out what will be the torque here, where torque is nothing but it's a effective brake load. It's a effective brake load, that's nothing but it's a W minus S, and we need to take the radius of the brake drum. So, this is what the torque here. Okay, the torque is nothing but it's a effective brake load into the radius of the brake drum here. Now, this effective brake load he has given in terms of the kg he has given, that is a 500 kg is given. So, but we should have to substitute in this formula in terms of the Newton here. Okay. Now, therefore, I will just take, this is a 500 given gauge is there, I will just multiply 9.81, so that I will get this W minus S in terms of the Newton. Now, what is the RB here? That is the radius of the brake drum. So, to find out the radius of the brake drum, so he has given the mean circumference is given. Okay. So, he has given that mean circumference. So, this I will take here RB. So, we know that. So, given. So, this was the mean circumference he has given, that it is a 400 mm he has given. So, mean circumference means I can take, this is a 2 pi into RB. So, this is 400. So, I can calculate here RB, that is the radius of the brake drum. So, that is a 400 by 2 pi, which gives the value is 63.66 mm. So, what we are getting the value after simplification. So, but I need to substitute here in terms of the meter. So, I will just take this 63.66 mm in terms of the meter here. So, this RB is equal to, I will just take 0.06366 meter. So, now this is the radius of the brake drum. Now, this value I will just substitute here, so that after simplification I can get the what is the value of our brake power. Now, therefore, brake power is equal to, so before that I just calculate what is the torque here. You just take this value in this case. So, therefore, T becomes, it is a 312.25 Newton meter. So, this is our torque which is developed by the engine here. Now, the next thing is what we need to find out, what is the brake power. So, by using this formula, so brake power becomes, it is a 2 pi, N is our given speed, that is a 300 rpm. Now, the torque what we have got, it is a 312.25 Newton meter by 60,000. Now, we just simplify this, we will be getting a brake power as some 9.81 kilowatt. Okay. So, it is a 9.81 kilowatt. So, this is what the brake power which is developed by the engine here. So, finally, we will go for the what is the mechanical efficiency. So, third one is we need to find out the mechanical efficiency which is given by, it is a ratio of brake power to the indicated power. I will just take in terms of the percentage here. Okay, I will just simplify here. So, mechanical efficiency becomes, so brake power is our 9.81 kilowatt, and the indicated power what we have got is, it is a 14.14, and this is percentage. I will just take in terms of percentage. So, finally, the mechanical efficiency becomes somewhat 69.38 percentage. 69.38 percentage. So, this is the mechanical efficiency 69.38%. Okay, the problem is very simple. Only thing is what, somewhere here we have to be just concentrate here to calculate the what is the torque here, that is given by the effective brake load into radius of the brake drum. Now, effective means we should have to consider both the thing, like dead weight. So, where W indicates it is a dead weight and the S indicates a spring balance reading. By considering both the things here, it gives the value of a effective brake load. Okay, now this is what the very simple problem here. Okay, if you like this video, please comment, share it to your friends and subscribe to our channel.